phase 2 system. Well, let's try it. Well, we can have the first digit, and a 0, correct? And we can also have a 1, correct? But we can't have a 2, so we have to add another place marker, and we get 1, 0. So we had 0, then we had 1, and then we had 2. So this is how you illustrate 2. If we keep doing it, so if we add 1, this is 3. Then if we add another 1, well, we have to add another place marker because we can't have any extra numbers. Because we can only go to 1, we can't go to 2. So now we get this, 1, 0, 0. And this is equal to 4. So as you can see, when we have one place marker, and we can have up to 1, this is equal to 1. When we have 2 place markers, well, this can be equal to 2, because we get 1, 0. If we get 1, 0, 0, this is equal to 4. So as you can see, rather than multiplying by 10 each time, we multiply by 2. So if we have a binary number, such as 1, 0, 1, 1, 0, 1, you could say 1's place, 2's place, 4's place, 8's place, 16th place, 32nd's place. So it multiplies by 2 each time rather than 10. So let me make that a little clearer because that was kind of smashed up. So if we have 1, 0, 1, 0. Well, this is the 1's place. This is the 2's place. 4, 8. So what number is this? Well, we have 2 and we have 8. So the answer is 10. Alright guys, so now you can see we have this binary number floating in the sky. Well, this is obviously equal to 0. It's the only number we have. Well, if we want to represent a 1, we can replace this 0 with a 1. Well now, since the only options we have are 1 and 0, we can't place a 2. The only thing we can do is move this to the next spot. So now, we have 2. You see? So we went from 1 being 1, and then to make it 2, we scoot it over and add a 0. So that's 2. Now if we want to represent 3, well, we add a 1. Well, this isn't a 1, so that means we can just replace it. This is 3. Well, now let's say we want to add another 1 to make it 4. Well, as you can see, we can't represent these as 2's because we can't use 2's. So the only thing we can do is add a 1 and replace them with 0's. So what number is this? First we had a 1, and then we had 1, 0, which is 2, and we had 1, 1, which is 3, and then we had 1, 0, 0, which is 4. Okay, so now how do we represent 5? Well, 1, 0, 1. 6, well, we can't add a 1 here, so what we need to do is we need to move this up and replace that with a 1. So now we have 6. 7. And then if we want to add another one, well, we can't because we can't have a 2. So that means all of these become 0's. Scoot them up here. And we add a 1. So here we have 8. Now if we want to represent 9, add a 1. If we want to represent 10, well, we have to scoot this up 1 and add a 0. So this is 10. So here is what each spot represents. And we can keep multiplying this by 2 for as long as we wish, but this is as far as we are going to go. So if we have a 1 or a 0 here, it can only be a 1. So this means that's 0 because that's off. So we don't count 1. Then 1 is 1. Well, if we are looking at other numbers, let's say we have 101. Well, this is 1, this is 4. So the answer is 5. Okay, I guess I can use some decimal numbers to represent this. So this is 5. Alright, so now what if we have 111? Well, this is 4, this is 2, and this is 1. So we get 4, 5, 6, 7. So this becomes 7. Alright, now I want to try adding 1 to this binary number. Well, we can't add it here, so that means we have to change something because there's nowhere to place this. We can only place it at the far right. So that means 4, 5, 6, 7. We can scoot these all up to 8 and add in the zeros. So that is how that works. We went from 3 1s, which added up to 7, to 1 1 that added up to 8. So if we were to go to 9, all we need is an 8 and a 1. If we were to go to 10, all we would need is an 8 and a 2. If we were to go to 11, we would need 8, 9, 10, 11. If we were to go to 12, we would need 8, 9, 10, 11, 12. So basically, we use these numbers to add together to give us the number we want. So right now we have 12. If we were to use 13, 13, 14, well, 14. There we go.